Okay guys, we're going to talk about graphing and writing piecewise function. Hopefully the discovery that we did today helps you kind of understand that you're taking pieces of each graph and you're piecing them together to make one graph. Piecewise functions are pieces of different functions all on one graph. The function is given by different expressions on various intervals. Okay? So if we're looking here, we're going to evaluate piecewise functions. Complete the following example. So we have x minus 2 when x is less than 0, and then x squared plus 1 when x is greater than or equal to 0. So if I am looking when x is negative 4, I go up here and I look at the interval and I'm like, which one of these intervals would x equals negative 4 lie in? So I ask myself, is x less than 0 at negative 4 or greater than or equal to 0? And hopefully you can figure out that negative 4 is less than 0. So I'm going to use this first function to evaluate. So I'm going to take the negative 4 and put it in place of x. Negative 4 minus 2 is negative 6. So I know when x is negative 4, y is negative 6. Okay? So f of negative 4 equals negative 6. All right, 0. Is 0 less than 0? No. Is it greater than or equal to 0? So we're going to use this function because it's equal to 0. So we're going to plug that in. We're going to get 0 squared plus 1. So f of 0 equals 1. All right, 3. Is 3 less than 0 or greater than or equal to? Greater than 0. So we're going to do 3 squared. Be careful if this has been a negative 3. You'd want to make sure you put parentheses around that. Plus 1. So 3 squared is 9. And 9 plus 1 is 10. So when x is 3, y is 10. So that's how you evaluate. And that's going to be your delta math later on for practice. All right, so let's look at graphing piecewise functions. So first of all, you're going to create a table of values for each piece of the function. Be sure to include your interval values. Then you're going to ask yourself, is it an open or closed circle? Remember, if it's greater than or less than but not equal to, it's open. If it's greater than or equal to, less than or equal to, it's closed. So don't forget that. And then you're going to plot your points. So on this first one, we have two functions here, and we know in the first function it's the square root of x minus 3, so x is greater than 4. Now we can't start with 5, we have to start with 4, so we're going to do like 4, and then I'm going to try to think of some that will come out as a perfect square. So I need like 7 minus 3, so I could use 7, and then the next one would be 9. So I'd need 9, the square root of 9, so 12 minus 3 would give me 9. So I'm going to use 12. So these are just going to give me some examples where I'd have whole numbers come out. So if I have the square root of 4 minus 3, I get square root of 1, which is equal to 1. Now you could use the numbers 5 and 6, but those are going to give you decimals and not get you very much bigger. So I'm just trying, and then here, 7 minus 3 is the square root of 4. That's going to be 2. And then 12 minus 3 is 9, so that's going to be 3. All right, so at 4, it's greater than, but not equal to, so that's going to be an open circle. So let's go over here and plot our points. At 4, 1, open circle. And then 7, 2 is just another value. And then it would just keep increasing. This is, if you remember, it's kind of curves for square root functions. So that's going to be how that works there. Then on here, we have negative 2x plus 4 and greater than or equal to 1. So I could use 1, 2, 3, 4. When I plug 1 in, I get negative 2 times 1 plus 4. Negative 2 plus 4 is positive 2. Then I plug 2 in. That's going to give me 0. And then I plug 3 in. That's going to give me negative 2. And then I plug 4 in. Negative 8 plus 4 is -4. You could go on to 5 and so on and so forth, okay? But let's look. So this is going to be a closed circle because it is equal at the 1. So we're going to go to 1, 2. And then we're going to do 2, 0. And then 3, -2. And then 4, -4. And this is a linear function, so I know it makes a straight line. So that would go that way. Now, if we looked at this function, is it continuous? Can I draw this entire graph with never lifting my pencil? No. So this would be a non-continuous graph because it does not continue. Now, anytime you have an open circle, it's going to be non-continuous because you'd have to jump over that. It's kind of like a ditch. Okay, so let's look at this next one here. I didn't give you the little T-chart because I wanted you to be able to do it because it won't always be there. So this first one, we have g of x, which we also know as y, equals -1. So in that case, every time I'm going to get a y, I know it's going to be -1. So I can use any x values, okay? I could use like -2, 0, and 2, okay? But what do I have to check before I choose my x value? So this is an important part. Can I use -2? Can I use +2? So these are things, can I do that? No, because it has to be less than or equal to -1. I can't even use 0. So let's talk about it. So I need -1 and numbers less than -1. So I could use -4, -3, -2, but I also need -1 in here because it has to go up to -1. This is going to be a closed circle at -1. Okay, so we're going to go over here, -1, -1, -2, -1, -3, -1. Now, anytime y equals -1, we should know now it makes a horizontal line at -1. And then this is going to continue to go off to the left. Okay? So that's that first one done. Okay, now let's look at the next one. In this case, y is always 1. And then I need to go from -1 to 1. So -1, 0, 1. Okay, this first one at -1 is going to be open, and then this one's going to be closed. So let's look, -1, +1. Okay, that's going to be open, 0, 1, 1, 1. And that one's going to be closed. Now, the numbers in between are always closed. It's just your start and your end that you have to determine. And that's going to be that line right there. Those 3 dots between -1 and 1. That's that graph. Okay? So this side was open and this was closed. Okay, the last one. This one's y equals x, but where x is greater than 1. So I start at 1, I do 2, and I do 3, and I could go on to 4. When I plug 1 in place of x, y becomes 1. 2, 2, 3, 3, so on and so forth. This is going to be an open dot to start with at x is 1. So I get here 1, 1. Oh, but it's already closed from the previous graph. So I can't open a closed dot, okay? So it stays closed. If you fill in a hole with dirt, it's no longer a hole. It should be level. And then you have 2, 2, 3, 3. And so this one's going to continue to go like that. Now, if it was only this part of the graph could be considered continuous. But see here how you're having to jump from here to here, so that's a non-continuous. Okay, let's look at this last part here, and then we will be done with the notes for today. So we've got 2 functions here. So we're going to go less than -2. So we're going to have like -5, -4, -3, -2. Okay? When I plug -5 in there, okay, we can go over here and we can take this y and we can move it over here. And then this could be y equals x squared plus 3. So it'll give you room to work it out. So you're going to have negative 5 squared plus 3. Negative 5 squared is 25 plus 3 is 28. Most likely that's not going to graph on my graph. Okay, then I'm going to have negative 4 squared plus 3, and that's going to be 19. Negative 3 squared plus 3, and that's going to be 9 plus 3 is 12. And then negative 2 squared plus 3 will give me 7. Okay? Here at negative 2, this is going to be an open circle. So negative 2, 7, negative 2, 7, open. And then negative 3, 12 would be up here. So that graph there would be like that. And it's kind of curved because it's a quadratic. If you remember, it's a U shape. Okay. The next one. We get this. And now we're going to go from negative 2 to 2. So negative 2, negative 1, 0, 1, 2. Okay, and they're both going to be closed. So at negative 2, I put that in there. 5 minus a negative 2. 5 plus 2 is 7. And then 5 minus a negative 1. 5 plus 1 is 6. And then 5 minus 0 is 5. 5 minus 1 is 4. And I think we could do this and realize that 5 minus 2 is 3. Alright, so they're both closed. Negative 2, 7. Negative 2, oh, but that's open. But we have to close it because remember, if you think of cards, a closed circle trumps an open. Negative 1, 6. 0, 5. 1, 4. And then 2, 3. I have to look over here. That's my last point, and so it's going to be closed too. And then we're going to connect those dots. This is a continuous graph. It doesn't have any spot that I'd have to pick up my pencil and jump over. Alright guys, you're going to have some practice on this today, and then we'll do some more on Monday. Reach out. This is probably something new, and I know sometimes it can be confusing, but you just take it one at a time. Check plan book for your assignments. Have a great day.